In this video we pay attention to recurrence relations. Is the second application. I have made a previous video about solving how to solve a recurrence equation. So now we have this recurrence equation: xn plus 2 plus 5 xn plus 1 plus 4 times xn is equal to 0. So given that x0 is equal to 1 and x1 is equal to 3, we would like to find a formula for xn. Of course, the first step is to use this ansatz. Xn is equal to omega equals omega to the power of n. Now, if we substitute this ansatz back to the recurrence equation, we will obtain the following. Now, this equation can be written in the following way. And we can convert this equation to this form. This is a quadratic equation. We can compute the roots. First, we compute the discriminant. We find the two roots omega plus and omega minus. And we also find the other root, omega minus. Of course, now xn can be written in the following form. So is c1 omega plus to the power of n plus c2 omega minus to the power of n. So this is the general formula for xn. c1 times minus 1 to the power of n plus c2 times minus 4 to the power of n. And c1, c2 are real coefficients. Here are arbitrary, but we can employ these initial conditions over here to find a particular solution. So given that we have two conditions, we can use these two conditions to give appropriate values to C1 to find the desired values of the constant C1 and C2. Now let's employ these two conditions. So let's rewrite a bit what is the xn. So it's C1 times minus 1 to the power of n plus c2 times minus 4 to the power of n, this relation here. So x0 is c1 times minus 1 to the power of 0 and this is equal, so x0 we know from the initial conditions is equal to 1, so we obtain this relation over here. C1 plus C2 is equal to 1. Now let's use the condition that x1 is equal to 3. For n equal to 1, we have C1 times minus 1 to the power of 1 plus C2 times minus 4 to the power of 1. So this is minus C1 minus 4 C2. This is equal to 3. Minus C1 minus 4 C2 is equal to 3. So we have this linear system to solve in order to find the values of C1 and C2. We add by parts both parts of the equation, so we have minus 3c2 is equal to 4. So c2 we solve this linear system, we add these two equations together, and we have minus 3c2 is equal to 4, so c2 is minus 4 over 3. Now we use this equation in order to determine the value of c1. c1 is 1 minus c2, so is 1 plus 4 over 3. So this is 7 over 3. So xn will take the following form. The constant c1 is 7 over 3 times minus 1 to the power of n minus plus c2, which is minus 4 over 3 times minus 4 to the power of n. Let's go to make a brief review of what we have done. We have the recurrence relation, this recurrence relation, and we would like to find xn, given that we have these two conditions. We use this ansatz, we substitute, which means that we plug in this expression back in this recurrence equation, and by doing some trivial computations, we obtain a quadratic equation. We find the discriminant, we compute the two roots, and then we write the general form of xn in this way: c1 times omega plus to the power of n plus c2 times omega minus to the power of n. These c1 and c2 are real coefficients, and we obtain this relation where we have a general expression with c1 and c2. Now, in order to define the c1 and c2, we use the initial conditions over here. So, for n equal to 0, we obtain this relation over here. For n equals 1, we obtain this equation. We have a linear system of two equations. We have this linear system, and from this linear system, we first compute c2, and then we compute the c1, and we obtain an explicit expression for xn, where now we know what are these constants are. I would like to thank you for watching the video, and I really hope that you are having a great time.